Good morning, guys. Anjani Kumar here, dealing instrumentation subject for a final year electrical students. Right. In a last session, we discussed about thermocouple and thermistors. Right. How the working principle and how the construction and advantages and disadvantages that we discussed. Right. I just want to give a brief idea on thermistor and the thermocouple. So with this, we'll start the session regarding piezoelectric transducer. Right. So first I'll explain the brief things about thermistor and thermocouple. So after that we'll start the session. Alright. So what is a thermocouple? So what is a thermocouple? I just want to explain the basic working. I just want to explain the basic working principle. That's it. We just give get brief idea on that. What is a thermocouple and what is a thermistor, right? I explained in detail in our previous sessions, right? So what is a thermocouple? That means when two dissimilar metals, so which are joined together, it forms two junctions. Right? So junction J1 and junction J2. So one junction we can call it as a cold junction, another junction called as a hot junction. So cold junction is at 0 degrees centigrade, that is called a reference junction. Hot junction, whatever the temperature. So what is a thermocouple? It is used to find the temperature in a metal. Alright? It's a transducer. Alright? So thermocouple means it is used to find the change in temperature across the metals. Right? So it is having two dissimilar metals which are joined together. It forms a two junction. One junction we can call it as a cold junction. That is called a reference junction at 0 degrees centigrade. That you are assumed, right? Another junction we can call it as a hot junction. When whatever the temperature, if you want to find, that can be applied across the hot junction. That means change in temperature will produce the EMF, right? According to the Thomson, Peltier, Seebeck effects. So these change in temperature will produce the EMF. That EMF we can find out with the help of a standardized meters that we have, voltmeter, moving coil meters. So whatever the voltage that you will get, which is analogous to the change in temperature. So that's about the working of a thermocouple. Different metals we can use. So the iron constantan, copper constantan, chromium constantan. Right? Also different metals that we discussed earlier. And what is the equation? E is equal to A into del theta. This is the equation for the EMF and the change in temperature. We'll get the scale as a linear. Right? So this is about thermocouple. Right? Now, what is a thermistor that we discussed? I just want to give a brief thing, that's it, right? So, thermistor. Alright, so thermistor, which is nothing but a thermal resistor. It is also used to measure the change in a temperature, measure the temperature, unknown quantity, by measuring the change in the resistance. Alright? So how it can work means it's nothing but a negative temperature coefficient and positive temperature coefficient. You have two types of thermistors, negative temperature and a positive temperature. If the temperature increases, your resistance is going to be increases. So the examples are RTD and fuse. So these are the positive temperature coefficient thermistors, right? So what is NTC? So always the thermistor or a negative temperature coefficient. So that means if a temperature increases, the resistance is going to be reduces. Right? So these are made up of semiconductor materials, because these type of semiconductor materials will exhibit the property of negative temperature coefficients. Right? So these are made up of gallium, arsenic, right, manganese. So these are semiconductor materials. Alright, so these type of thermistor those can available in different shapes, like bed shaped, disc shaped, and spherical shaped. So depends on how much pressure, how much temperature that you want to find. So in that different types of shapes, those are available, right? So that means whatever the temperature resistance characteristics are always non-linear in this type of a thermistors. Those are very less in byte. So whatever the cost when compared to that RTD, positive temperature coefficient, these are very less cost and more sensitive. That means for 1 degree centigrade you are getting a 5% change in resistance, and that means it is used to find the minute change in the resistance, right? So what about the EMF equation? So the change in resistance R2 is equal to R1 into e power minus beta 1 by T1 minus 1 by T2. So this is the equation for changing a resistance. So when you got the changing resistance that can be calibrated, that means that can be applied to the Wheatstone bridge, then you will get the voltage. So whatever the voltage that you are getting, that is analogous to the temperature that you are applied. So with this, this is the way how the thermocouple and the thermistor work. So thermocouple, which is an active transducer, also it doesn't have any auxiliary supply for this transducer operation. All right. So that's about the things that we discussed till now. Now we'll discuss about very important concept called piezoelectric transducer. Right. So what is piezoelectric transducer? So before going to this, so what is piezo effect? Right. So what is piezo effect? So piezoelectric. What is piezoelectric? So piezo means squeezing. Correct. So electric means charge. Right. When you squeeze a crystal, definitely there will be a charge accumulated on the crystal. So piezo means squeezing. If there is a crystal now, if it is a crystal, right? So it is a crystal. It is a crystal, right? So when you squeeze nothing but you are applying some force or a pressure. So definitely there will be a charge accumulated in it. Alright, so there will be a charge accumulated in it. So this phenomena we can call it as a piezoelectric. You know, when squeeze something, definitely there will be a charge accumulated. So that is called a piezoelectric. So what is a piezoelectric transducer? So I'll write it out. So piezoelectric means when force applied on a crystal, so then there will be charge accumulated. Right? That is called piezoelectric. Hope it's clear, right? When there is a crystal, so when you apply a force, that is nothing but you are squeezing, so there will be a charge accumulated on that crystal. So this phenomena we can call it as a piezoelectric. So this can be invented in 1880 by Pierre Curie and his brother F. Curie. So both are club and invented this concept of piezo effect. So how it will generate the charge and all these things. But it's entirely different for us. Just we need to know what is a piezoelectric. So what is a piezoelectric means? Piezo is nothing but squeezing. If you squeeze something in a crystal, definitely there will be a force there will be a charge is going to be accumulated. Right? So what is piezoelectric transducer? So what is piezoelectric transducer? So this is a crystal. So this is called a crystal, right? So when you apply a force, or a pressure, right? What happens? There will be a charge accumulated, right? So there is a charge means there will be a current is going to be generated. So due to that current, you will get you will connect one meter, right? So moving coil meter, it is moving coil meter. So whatever the charge that can be flows, and it will moves the deflection. So definitely it will reach the voltage. So whatever the voltage that you are getting is equal to the applied force, or a strain, pressure, whatever it may be, strain, pressure, whatever it may be, right? So whatever the force that you are applied, that is converted into voltage. That means, so there is a charge is going to develop now. This charge will close to this, and the coil deflection will take place. This type of deflection we will read out with the help of voltage and current, voltage, whatever it may be, right? So whatever the voltage that you are getting, which is analogous to the force that you are applying. So it's like a transducer, one form of energy which is converted to another form of energy. So that is a concept of piezoelectric transducer. Right? So that means whatever the force or pressure which is converted to the voltage. Right? So from that you will see, is there any external supply for this operation? Definitely not. So that means whatever the piezoelectric transducer, we can call it as an active transducer. So what is the definition? That means the force or strain or pressure which is converted to voltage in a crystal. Alright, so it is nothing but an active transducer. Right, so that means we don't have any external supply for this operation of this transducer operation. So that's why we are calling these type of transducers or active transducer. Alright, so this is the concept behind piezoelectric transducer. Now we'll see how the charge is accumulated, right? So this is a crystal. You are applying a force, right, or a pressure, right? So this pressure must be a dynamical pressure, not the static pressure. So very, very important question. The pressure you are applying, dynamic pressure, a dynamic force, not static. Right? We'll see how when you apply a static force, what happened to the voltage. There will be no voltage when you apply a static force on the crystal. So so whatever the force that you are applied, so that is a dynamic pressure or dynamic force, and then the charge will be accumulated, right? So this charge is very small value, right? So this can be find out with the help of a charge amplifier over here. Charge amplifier. So whatever the amplifier which amplifies the charge, and there will be a current is going to be flow. Right? This current, one moving coil meter is going to be connected here, voltage coil. So whenever the current flow, this deflection will take place. So this deflection will reach the how much voltage is generated. So whatever the voltage which is analogous to the force that you are applied. Right? So like that the crystal, whatever the piezoelectric crystal transducer working. I hope it's clear. Why charge amplifier means whatever the charge you are getting, which is very less. Right? So the charge you are getting is very less. So for this we need a charge amplifier, so which amplifies the charge. So thereby the current is generated. Due to that current, the meter deflection will take place. That can be identified with the help of a moving coil meter, how much voltage is going to be generated. So whatever the voltage which is analogous to the force that you applied. I hope it's clear. We'll see from here. So whatever the charge which is directly proportional to the force that you apply. Any doubts? No. So how much charge generated means how much force that you applied. So if you remove the proportionality, which is nothing but d by f. So whereas d is nothing but q by f. Here d we can call it as a charge sensitivity. So it is nothing but output, that is nothing but input. So it's nothing but charge sensitivity. So what is the formula? Coulombs by newtons. Right? So D we can call it as a charge sensitivity. Very, very important. So how much force you apply, that much charge is going to be developed. So D is nothing but Q by F. So that is nothing but output by input now. So we can call it as a sensitivity, right? So we can call it as a charge sensitivity. So mainly charge sensitivity depends on the direction of a force that you applied. For suppose if you apply a force in this direction, so like F11, so definitely there will be a charge sensitivity in this direction, or whatever it may be, right? If you apply a force in this direction, F22, you will get the charge sensitivity, you will get like this. So definitely whatever the charge sensitivity, that must be depends upon what direction that you are applied. So that means the overall sensitivity. So that means the overall sensitivity of a crystal, that depends on what type of directions that you applied a force. So that is an important criteria while defining the sensitivity of the crystal. Alright. So what is the sensitivity of the transducer? So the D is nothing but overall sensitivity, that we can call it as a D11 square plus D22 square plus D33 square and so on square root of. Right. This is the overall sensitivity. Right. So this is the overall sensitivity of the piezoelectric transducer. I hope it's clear. So whatever the charge sensitivity must be depends on the direction of the force that you applied. So if the direction is one direction, definitely there will be a charge sensitivity in another direction. That means your charge sensitivity must be the directional, depends on the force. So this is the equation for the overall sensitivity of the piezoelectric transducer. I hope it's clear. Right? Now we'll see. So why, if you apply a static force, what happened? We'll see. Right? So this is a crystal. Now you are applying a static force. Right? So this is a static force. Static force means you just applied once and remove this force. So definitely what happened? There is no vibrations. Just there will be small charge is accumulated. That's it. The charge would move. Right? If the charge is moving only, your current is going to be generated. Thereby the voltage you can find. Right? So whatever the static force means you just applied once and just remove. There is no vibrations. So whatever the charge accumulated is very less. So with this there is no current, there is no voltage. That means if a static force that you applied, there is a voltage is zero. Very, very important. In a gate, I think almost 3 or 4 times this type of question repeated, right? So when a crystal, piezoelectric crystal, if you apply a static force, there is no voltage developed. Right? Always you just apply a dynamic force. So then what happens if you apply a dynamic force means keep on moving. There will be a vibrations. So due to that vibration, this charge is going to be accumulated. This charge is going to be moved. So these type of different charges are going to be developed. So due to that, there will be a flow of electrons. So it will constitute the current. So the current is going to be find out. So due to the moving coil meters, there will be a voltage is going to be generated. This voltage is analogous to the force. So always you are going to apply a dynamic force. So if you apply a static force, whatever the voltage that are generated will be zero. Hope it's clear. Alright. Now, what is the relationship between the charge and the pressure or the force, whatever the voltage and current relationship that we want to derive, right? Right. So you know that Q is directly proportional to F. So Q is nothing but dF. So where D is nothing but Q by F. So this is called a charge sensitivity. Okay. You know that when you apply a force, there will be a charge accumulated, means it acts like a capacitance now. Right. So whatever the formula for charge, Q is equal to CV na, you know the formula, C V or nothing but whatever the applied voltage, right? I hope it's clear, right? So what is the formula for capacitance? C is equal to epsilon A by D na, right? So epsilon is nothing but permeability, relative permeability, that is nothing but area of the crystal. So we can call it as a T. T is nothing but thickness, right? Thickness. So this is called a thickness of the crystal, right? You just apply here. Q is nothing but Cp. So what is called Cp? Cp is nothing but epsilon A by T into E, right? Any doubts? So from this, what is Q? So here you can substitute the Q value. So Q is nothing but dF now. You just apply dF is equal to epsilon A by T into E, right? Alright, so from this, so you can write it as, so but you require a voltage now, so E by T is equal to D by epsilon F by A. I hope it's clear. So E by T is equal to D by epsilon F by A, right? So this we can call it as a stress. So voltage per unit. So voltage per unit length we can call it as a voltage stress. Right? So this we can call it as a pressure. So force per unit. So we can call it as a pressure. Right? So whatever the voltage stress, so this we can call it as a Z. So this is called voltage sensitivity. So here D is nothing but a charge sensitivity, Q by F. Here we can call it as a G, we can call it as a charge voltage sensitivity. It is nothing but D by epsilon. So you can write it as D by epsilon naught, epsilon r also. So that means whatever the voltage that you applied across, that is depends on the pressure that you applied. So how we can write it as? So from this, let's write it out here. You will get E by T is equal to D by epsilon F by E. So this we can call it as a E by T is equal to Z into pressure. Alright. So Z is nothing but voltage sensitivity. So you know that D is nothing but Q by F. It is a charge sensitivity. Alright, so what is a G value? G value is nothing but voltage sensitivity. So that is equal to D by epsilon. So that we can call it as a D by epsilon naught, epsilon naught. Right? So this is very, very important. Alright. So you know that what is a voltage? E is equal to ZPT. It is a very, very important. So whatever the voltage that is generated in a transducer is ZPT. So Z is nothing but voltage sensitivity. Right? So P is nothing but pressure that you applied. Right? So T is nothing but thickness of the crystal. Right? So this is about piezoelectric transducer. Right, what is a piezo effect means? When you squeeze a crystal, definitely there will be a charge accumulated. So this charge is going to be standardized with the help of a moving coil voltmeter. So whatever the voltage that you are getting, which is analogous to the force that you applied. So this is the working principle of a piezo crystal, piezoelectric transducer. So that means whatever the pressure, whatever the force that you are applied, that will be always a dynamic. Alright, so definitely it's an active transducer, doesn't require external electrical supply. So whatever the charge sensitivity, D is equal to Q by F. So it depends on what direction that the force that you have applied, so that much sensitivity is going to be developed. So the total sensitivity, you know the formula, square root of D11 square plus D2 square, so and so on. Right, now what is the relationship between the output and input? So you know that E is equal to GPT, very important relationship. Definitely you will get a question, you will get a problem. So G is nothing but voltage sensitivity, right? So T is nothing but thickness of the plates, thickness of the crystal, and P is nothing but pressure that you are applying, right? Now this piezoelectric transducer, it works as an inverse transducer also, right? Very important, right? It works like inverse transducer also. Right? So that means whatever if it is a crystal, right? So when you apply a voltage across the crystal, so definitely there will be a vibrations is developed. That means there will be a squeezing. So when a voltage is applied across the crystal, there will be a vibrations is going to be developed. So this type of transducer, it also electrical energy which is converted to the force or vibrations. It's like a inverse transducer also. That means works like inverse transducer also. So that means whatever the voltage that you applied, it will convert it into vibrations. So that means whatever the electrical energy which is converted to another non-electrical quantity. So it's nothing but inverse transducer. Okay, inverse transducer. So this is about the whole concept regarding piezoelectric transducer, right? What are the points that you want to note down? Means what is a piezo effect, right? How it will convert it as a piezoelectric transducer? What is a force or a stress or a pressure that is going to apply that can be converted to voltage, right? So what is a charge sensitivity, right? The Q is directly proportional to the force that you applied. D is equal to Q by F. So that is called a charge sensitivity. Charge sensitivity must be depends upon the direction of the force that you are applied, and after that how much voltage is generated. So that can be identified. That you know the value of G is equal to GPT, where G is nothing but voltage sensitivity. So what is the formula for voltage sensitivity? D by epsilon, right? So whereas P is nothing but a pressure that you are applied, T is nothing but thickness of the crystal. Right? So piezoelectric transducer is an active transducer that doesn't require any external supply. So whatever the force that you are applied across the piezoelectric transducer, it must be a dynamic force. So if you apply a static force, there is no voltage across the piezoelectric transducer. Right? Always you are just going to apply only a dynamic motion. Right? So whatever the piezoelectric transducer, it also works like a inverse transducer. That means when you apply a voltage across a piezoelectric crystal, so there will be vibrations you will get. That means the force that you are getting. So whatever the voltage that is converted to the vibrations. So whatever the electrical quantity which is converted to non-electrical quantity, it acts like a transducer, inverse transducer also. This is the whole concept regarding piezoelectric transducer. And we have one of the last concept called photodiode and synchros. We don't have that much concept because you know about synchros very well. So you did the experiment also. So that's why I don't want to explain the concept of synchros. Right? Only one concept is there, that is called photodiode. So in the next session, we will deal the photodiode concept. So with that, we will end this entire unit. All right. Thank you very much. We'll see you in the next class.